Welcome everybody to the Jones Edmunds Engineering Rocks podcast. I'm Ken Vogel. I'm the Managing Director of the Civil Environmental at Jones Edmunds, and I am your host for today's show. Each month we will have a podcast. We'll bring to you some exciting guests and topics really related to everything related to sports. No, just kidding. We'll talk about engineering. I wish I'd rather talk about sports, but we'll talk about engineering. And as my guest and I are talking, please send in some questions through the chat function. So we'll keep an eye on that. And if you have a question, along that topic, we will, I'll jump in with that, or we'll leave some time at the end for some questions and answers also. So again, use the chat function. Put your name in there so we know who's asking that question. That way Tim can address you specifically. So I want to welcome our first guest to the podcast is Dr. Tim Townsend. Tim is the Jones Edmunds Professor of Environmental Engineering in the Department of Environmental Engineering Sciences at the University of Florida's Engineering School of Sustainable Infrastructure and Environment, also known as ESSIE. Say that 10 times fast. Tim is a recognized international expert in the discipline of solid waste and hazardous engineering, whose research has resulted in hundreds of papers and publications. Dr. Townsend has consulted on landfills and solid waste issues throughout Florida, throughout the United States, and really throughout the world. He's examined landfill designs and operation strategies in many countries throughout the world. So Tim, I'd like to thank you for being here today.
Sure, Ken, my pleasure, thank you.
Hey, before we start trash talking, and I had to say trash talking at least once, before we get started, I wanted Tim to tell us a little bit, something about himself that's really not necessarily associated with engineering. And I know we talked earlier, and he had some exciting summer fun working hard doing something other than engineering.
Yeah, good. Thanks, Ken. Absolutely, I'll share a little bit. So one of the bright spots of being at home so much this year is the fact that we had two baby horses born in our place, two little fillies. And so my daughter is into equestrian and show jumping, and being the wonderful father that I am, we spent a lot of time together working on trying to breed some of our horses. And so I'm going to share a little with you since I have a captive audience right now. But earlier this year, we had our first little filly born, and that's little Clementine. You can see in between us. So she's a little Hanoverian. There's her shot. She's probably like 2 days old out in the paddock. Can you see that okay, Ken?
Yeah.
Anyway, she's a sweet little girl. We had the opportunity to bond with her, but it's just so amazing. These little guys, they're out there galloping literally the day they're born. And so that's her and her mom probably the second day after she was born. And then her sister, her name is Fury, her half-sister actually, was born about 4 months later. That's little Fury right there. And Fury's already out there right now running and jumping and playing. And she's a little Spitfire. And I took this photo just the other day. So that's the two sisters. So I had not anticipated this would be something in my life, but we've been having a great time. And the idea is that you're supposed to imprint on these guys when they're born. And so you get out there and right as they're born, you get them in that first hour to kind of to sniff you and to get to know you and to hear you and to recognize you. And now they're perfectly comfortable with us and people. And so it's been a great time. So Ken, thanks for asking.
No problem. And I know you did most of the work this summer as well with I think you said your daughter broke her arm, so you were the stable boy for the summer.
Well, at least for part of the time. She's back in the saddle again, so my manure shoveling is a little bit reduced right now.
There you go. Well, let's talk about some manure now.
Yeah.
Okay, let's dive into some landfill topics. Our first topic that we were going to talk about that every landfill really has to deal with, and really getting harder to deal with right now, and that is the disposal of leachate.
Sure.
As municipal wastewater treatments plants have become more stringent in meeting regulatory parameters, leachate's really taken off the invitation list, so to speak. And the landfills, they're being told their quantity of leachate has to be reduced or even severely limited or even no longer accepted. So, that leaves landfills, either have to haul their leachate to hazardous waste facilities, which can be costly, or find some alternative methods. So I know you've been doing a lot of research over the years about leachate disposal, with bioreactors in the past. Now I know you're working on some other ideas. So let's, where are we going with leachate?
Sure. So let's step back a second. In some cases, well, first of all, the easiest thing a landfill operator can do with their leachate, if it's available, is to either pipe it or truck it to a domestic wastewater treatment plant, which historically has always been the first approach. A lot of facilities still try to practice this. But Ken, you're correct, and I think most of the landfill folks on the call, the line, will agree that it's becoming more and more of a challenge. One question asked is, okay, well, why is that challenge there? Well, leachate is certainly much more concentrated than domestic wastewater, especially with respect to some particular chemicals, which we'll talk about. It's also very variable. It also, though, has a bit of a connotation, I think, with a lot of wastewater treatment plant professionals, that it's really bad stuff. And I'm not saying it's not. The volume is usually pretty small, but I would say that we're dealing with not only some real issues in terms of what's in the leachate, but also some perception issues about the fear of landfills and how any disruption in a wastewater treatment plant is very easy to go point a finger at the landfill. Some cases that might be justified. In other cases, it might not. One of the big challenges is ammonia. And so ammonia, of course, it's a nitrogen compound. And what happens is in a landfill, all the food waste, all the proteins, as that waste degrades, gets converted to ammonia. The ammonia concentrations are much higher than you'd see in domestic wastewater. Ammonia is a challenge in terms of treatment for any kind of wastewater treatment facility. And so one of the things that you're always going to have to look for is how do you handle ammonia? Things like the BOD or the organic demand. And I would even argue in a lot of cases that the heavy metals and such are probably not as big of a concern, but ammonia is a very legitimate concern. So number of things you can do. One of the, we do a lot of work, thankfully, we're very proud of and very appreciative of with local governments in Florida. One of the projects we're working on, and this is down in Polk County, is looking at a wetlands treatment system. What can you do if you have the appropriate site, the appropriate size to be able to try to more naturally treat some of that ammonia? There are certainly other pre-treatment steps you can put in place, but we're working on a fairly large wetlands leachate treatment system, which has some other units integrated into that. But that's not the right fit for every site, because if you don't have the right hydrology and stormwater and surface water measures, and you don't have the ability to recharge, that might not always work. And so other technologies that you hear more and more about, we've always been, something we've practiced at Alachua County a lot, is using membrane systems, reverse osmosis. And while that has connotations of being often real expensive or power consuming, I think there are ways that you can do that, especially if you are competing with hauling it to an industrial wastewater treatment facility. And then there are more and more kind of specialized technologies that you see out there. What I would say is that probably the solution for every site is going to be a little bit unique and a little bit different. Depends on the site characteristics, the amount of leachate, what's available, how much space. But I think that we're beginning to recognize that there are ways that we can try to maybe do things a little bit different. And if you can't get rid of it at a wastewater treatment plant, then developing your own pre-treatment system or treatment system on site is going to be something you see more and more of. Now, deep wells, a lot of facilities are turning in the direction of deep well injection. And if politically and socially you can get around the issues with that, then that is a pretty good, cost savings, long-term treatment system. You hear about evaporation. I think a few facilities in Florida are talking about that. So anyway, that's it. And then probably, I would guess, Ken, you might be asking me about the kind of big chemical of the day, which is PFAS. Is that right?
That was my next topic to bring up about leachate. That is a growing concern of PFAS. I know it's in the research phase, and so what kind of regulations do you see coming down, and how is that going to affect what we do with our leachate?
Yeah, no, it's a great question. And I would say that most of the facility operators have heard from either from me or from my colleagues at University of Miami about sampling at their facility. But anyway, so PFAS, it's this group of fluorinated organic chemicals. And there are literally thousands of these chemicals, and they're found in all sorts of different products. The firefighting foam is the big chemical that a lot of remediation sites are dealing with in airports and firefighter training schools. But in our clothes, in our food packaging, in our cookware, in our almost everything, in our garbage, there's a decent chance there might be some of these PFAS chemicals in there. There are two of them, PFOA and PFOS, PFOS and PFOA, that have kind of advisory water risk thresholds. But there are thousands of other chemicals. We just don't know what's there. So is it a concern? Well, there's definitely some recognized health issues, and it's in leachate, okay? So every landfill out there in this country has these PFAS chemicals in their leachate. Concentrations are, relatively high. We've done some work where you can go to a garbage truck at the transfer station, and you can take the leachate fresh out of the back of the garbage, and there's PFAS in it. So it's just not a surprise. It's in all of our waste. What's unknown, kind of like you intimated at, Ken, is okay, well, how is that going to be regulated and what it means? And quite truthfully, I don't think anybody really knows at this point. What you would expect is that the wastewater treatment plants are at some point going to have pressure about reducing the concentrations either in their effluent or in their biosolids. And that is only going to make them more suspicious of any kind of exotic source of wastewater like leachate. So what we've seen, it's in leachates. It depends on the type of waste as to how much is there or not, but it is something that occurs, and we believe that there are strategies that as we learn more that you'll be able to kind of address these at the landfill site. And then there are certainly some treatment options which are out there, but it remains a little uncertain on how well all these different treatment approaches work. We're currently right now working on a big EPA grant, and then coupling that with funding from the state of Florida and the Hinckley Center for Solid and Hazardous Waste, and then with all of our local government partners, trying to really explore what the issues are. Bottom line is that it's not going to be unique to anybody's facility in Florida. It's going to be something that everybody sees.
So you don't see this as a regulatory, regulations coming down anytime soon?
I don't think so. I think what you're going to see is this kind of gradual kind of introduction of, at first, kind of advisory levels or risk levels and thresholds. Right now, there is not even a true drinking water standard right now in the U.S. I mean, there are these kind of advisory levels, and states are beginning to treat them. And so if you have a remediation project and you have PFAS, the state of Florida, for example, has risk levels that they can use to target. But right now, you cannot be a hazardous waste because of PFAS. Under RCRA, there is no PFOA or PFOS chemical that could cause you or have, toxicity characteristic limit that would cause you to be a hazardous waste. It's not a listed hazardous waste. And so I was on the phone this morning with someone from EPA, and EPA is kind of leaning toward, if you have a lot of really highly contaminated PFAS wastes, that you send them to a hazardous waste landfill, which of course we don't have any in Florida. And I said, okay, well, the question though is, well, what makes it worth going to that versus say a class 1 landfill in Florida? I mean, what merits the risk? And so, but we don't know. I mean, because all garbage has it in there. And so at what point should you send it somewhere else versus just to dispose of it in a landfill? So it's certainly, I would say, something for the solid waste community to be aware of, to pay attention to. It's not something that I would have a lot of great urgent concern about big regulations coming down the line. I think in terms of impacting leachate and ability to treat it, it just adds to an already complicated issue and may make, in some cases, some utilities a little bit more suspicious, or more than anything, it'll give them an excuse because they didn't want to accept the leachate in the first place.
Yeah, that's what I see happening here. I see it becoming, at some point, it'll become that much harder for landfills to take their leachate to municipal plants.
Yeah.
All right, let's switch up the topic a little bit. And I do want to remind everyone that's online to, if you have a question, send it through the chat function. Make sure you send your name in so we know who the question's from. So we'll answer them as we go along. But the second topic that we were going to talk about is recycling. And, legislation passed in 2010 with a final recycling goal of 75% by our favorite year at this point, 2020. And there were some interim milestones, but that was always a concern, I think, throughout the past 10 years of can these communities make that goal, with collection costs and, just the markets for recycling materials and really getting the population to even just recycle. All those becoming issues. And now even in the past year or so with China not accepting waste, recyclables, and even now the past 6 months with the pandemic makes it even harder. So many issues, fighting against this recycling goal. And I know you've been looking at that topic as well for a long time, really.
Sure. Yeah. So, of course, this, even before all the troubles of 2020 occurred, recycling was under some, deep pressure, criticism, scrutiny in terms of its role in our waste management system. We've just become ingrained to incorporating recycling. It is something that citizens, residents want. Florida had a 75% goal. Not surprisingly, I think to some people, we could not meet it. And so the state of Florida is now at the point of, okay, well, what do we do next? And so I've been working with DEP and then a number of different professionals around the state, trying to examine what some of the next steps might be. Do you just, for example, put a different goal? Do you change it to another number and we continue to target that? One of the challenges with that that we've talked about, others have talked about, that what that whole legislation of getting to 75% did is it created this race to just find as many tons that you could count as recycling as possible, meaning that it didn't really matter what the environmental benefit was. It was just if I can add a ton somehow. And so even what was interpreted as being recycled changed over the years. So the idea of just chasing after tons for the sake of tons is, especially if you have limited resources, is not necessarily the smartest thing to do. What we've been kind of doing research on that I'm sure a number of you have seen us talk about is the idea of this concept of sustainable materials management, the idea that not all tons are created equal, and that depending on the material, recycling 1 ton of a certain material may have more benefit than another material. And so what you're seeing is, the EPA and a few states around the country, and then Florida's kind of embracing the concept, but is moving past just setting a straight recycling rate and saying, we're going to go after this percentage. And that maybe what we need to do is we need to figure out how to do a little bit more wisely, do it in a smarter fashion. And that means maybe prioritizing certain materials in the waste stream. One thing that is very evident from the work we've done is that the idea of reducing the amount of waste doesn't really get a lot of credit when you just have a recycling goal. In other words, if a community were to somehow reduce the waste stream, it would actually have a much bigger environmental benefit than recycling that waste, at least in most cases. And so how do you come up with a system that encourages or motivates or incentivizes waste reduction? I mean, we've been talking about that for decades, but implementing it into policy. So one of the things we're working on right now is that some of the local governments will be familiar with something called Waste Calc. And Waste Calc is it's essentially a program that was developed, decade or two ago, and it's to enable local governments when they submit their reports to DEP on an annual basis to estimate the amount of all the different materials in their waste stream, how much is going to recycling versus landfilling versus waste to energy. Right now, some counties, local governments will have composition of their waste stream because they did a waste composition study recently. Others won't. They'll know about how much of a specific material is recycled, but they don't know how much is going into the landfill or going into their waste energy plant. So Waste Calc does all that for them. Has to make a lot of assumptions, but the idea is that this program allows the local governments to be able to calculate that. What we're doing right now is we're trying to integrate into that sustainable materials management. So our hope is probably next year at some point, when the local governments begin to start introducing or using this tool, some of the data that will be provided back is not only, what their recycling rate is, but what, say, what their footprint might be, whether you're talking about a carbon footprint or greenhouse gas emission or water consumption, or even going as far as things like jobs and economics. I'll kind of leave it on in terms of recycling, one of the things that we've been looking at a lot is that I think it's a little unclear sometimes is what is the cost of recycling? Like here's a question I'll pose for you. You know that a local government has to, of course, hire somebody to go out and collect the recyclables. There's a cost with that. They also have to then pay somebody to take those recyclables and process them, to separate them and then market them. And there's a cost for that. Now, they're also not sending that to a landfill. So there's in theory some savings there if the markets exist. And then there's also a resale market for those materials. And so we've been digging back and trying to see, is there ever a time, because it makes sense, right? If the value of the recyclables are enough, there is a point that it would pay for itself. Now, the question is have we ever reached that point? And kind of looking at the data, certainly we're not there now. On a kind of a per household basis, under like the worst conditions that you would see right now in terms of the markets and landfill tip fees and things like that, you're talking $2, $3, $4, $5 a month per household is what it would cost to maybe have a recycling program under the worst conditions. Under the best conditions, you would actually kind of net out in that, you weren't actually having any additional cost to have that recycling. So it depends on the markets. But what you find though, is that for that $2 or $3 or $4 a month that per resident, and again, that's kind of subjective in terms of what someone thinks that important or not, the environmental savings are pretty substantial, especially when you compare it to other things like, the cost of switching from a gas car to an electric vehicle or to a hybrid vehicle. If you look at the extra cost associated with that versus the savings, you could argue that a local government is in some cases more wisely spending its money, even if they have to pay a little bit more for recycling. The key though is that if we could somehow focus on the recycling system being on the materials that have the best value and getting rid of these issues of contamination, you can actually get to a point that theoretically it'll save you money. But the trick is we've grown so accustomed to try to recycle as much as we can, we as residents and citizens aren't doing a very good job. And so over the next coming years, you're gonna have to see this kind of refocus and a message of recycling more isn't necessarily the right way to go. It's recycling better. And if you do it that way, it should make not only environmental sense, but economic sense too.
Right. And could you at this point say what you think are the top 3 materials that would make the most sense, and would it be the same in every community?
Not necessarily. If you guys follow the clippings and things like that, cardboard's doing pretty well right now. I guess, and this is the message that it's not just here at UF, but professionals in the state have been talking about for a while, is that if you can focus on the ones and twos in terms of the plastics and of course the aluminum and the steel and the higher quality paper products, there's value to that. The challenge of course is, glass isn't necessarily worth as much, and you're often paying to get rid of it, and the mixed paper and the mixed plastics. And so simplifying the waste stream in terms of the recyclable materials, again, if it's done right, that actually shows it should pay for itself in addition to all the other good it does.
Yeah, no, it's funny. I have reading the news clippings lately, and you see a lot of articles about issues with commingling and the public really not knowing what gets recycled, so they just throw it all in, and so a lot of times it just ends up all going to landfill anyway because the recycling plants can't accept that kind of material.
Right. But I guess one thing is that there are markets out there for materials. It's just that in some cases, depending on the economics, you may not be making that much money. And so it's not, you can't think of, at least in my opinion, that recycling is the program that you're doing to make money. The reason you're doing it, there's other reasons. The trick is how can I do it in a way that minimizes the cost and maximizes the benefit. And I think that, again, if you do it right, there are ways when the cost, it should either be break even or it's saving you a little bit of money.
Yeah, I agree. You know, I think each community has to determine for themselves, how much is that worth to them? You know, if you're gonna have to pay some for it, is that worth it for them? Is that what the community wants? You know, ultimately. And so yeah, that has to be all discussed. Now, one more thing associated with recycling, which is, you know, I think our final topic is ash reuse, and that's recycling of, you know, waste to energy ash and using it in, you know, typically in pavement designs. And I know Pasco County is using it, and I know you've tested a lot in the Solid Waste Authority of Palm Beach County. You know, you've used it there a few times. So and actually, we're about to use the mixed design in one of our Pasco County landfill projects. So I know you've done a lot of research on that as well.
Sure. So, of course, Florida has more waste to energy facilities than any other state. Ash management is always one of the, you know, there's a limit to what a waste to energy facility can control in terms of costs. It is not very lucrative to sell electricity under a lot of the newer contracts these days. Maybe if you still have a good older contract, but as these power purchase agreements get renegotiated, you know, making electricity is just not the big revenue source that it used to be, especially because it's so cheap to make it from natural gas these days. So the ash part of it is an opportunity if you could figure out a way to do something different that perhaps you can decrease costs to a facility. Now, ash is typically landfilled. You know, what we've seen is that it creates lots of problems when you mix it with garbage and it all goes in kind of a commingled landfill. You know, it just makes your leachate management that more difficult. You can dispose of it by itself in a monofill. Problems are a little bit less, but it's still, you know, you're still paying to do that, and it's something you're going to have to watch for a, you know, long time, if not forever in the future. So what can you do to try to recycle that? And Florida's been leading the way, and really thanks to the local governments here in Florida. It's not really been a big industry thing. It's been something that local governments in the state of Florida and the Hinckley Center have supported to make happen. But you start looking at what are some uses? Well, first thing is there's a big push right now for pulling out more metal, because there is some valuable, not only aluminum, but, you know, copper and precious metals that are in there that can be removed. And a number of facilities in the state have either ongoing or planned advanced metals recovery operations. So that's something you're going to see. The metal markets are maybe not quite as great as they used to be, so that kind of comes and goes. But then that's still only a small fraction of the mass. So the idea is that what can you do with the rest of it? And this, think for a second, what is waste energy ash? Well, it's not like coal ash, which is this really fine powder. Now, there's certainly some fine powder in waste energy ash, but it's primarily things that you throw in your garbage can that don't burn. And so there's going to be some glass, there's going to be some ceramic, a little bit of brick, a little bit of concrete, a little bit of metal, and then other things just that kind of melt together. So you have this kind of slaggy, glassy material. And then you have your air pollution control residues that are in there. If you just focus on the bigger stuff, you can actually, it's you know, something that if you look at it from afar, it looks like a pile of crushed concrete. So if you screen it and you get the metals out, the bottom ash anyway, at least looks like a good material. We've done work with combined ash too, where you can get an aggregate product out of that. But the idea is that you take this material and you use it, like you said, in pavement design. What I would say is, you know, the big markets are road base. You know, you're going to substitute it for rock that you would normally use under the road. That's kind of your most challenging because it's not encapsulated in any way. But like you mentioned in Pasco County, you know, we built that road out there before, and then Solid Waste Authority in Palm Beach County, they're going to be doing some similar work and have authorization to do some of that. You can integrate it into the concrete matrix, whether you're talking about Portland cement concrete or asphalt concrete. And there are other things you can do. We've been doing a lot of work lately looking at using it as a kiln feed in cement plants. Now, I'm not talking about concrete, I'm talking about cement. And this is something where, because of the iron and the aluminum and the silica and the calcium and the ash, you can put that as a kiln feed. and substitute it for other waste materials or other raw products that are going in there. So Florida still leads the way. Thanks again to the local governments who have decided they want to really get in this and explore this and begin to demonstrate it. I think you're going to continue in the coming years to see more and more progress on that. It's just one of those things that takes time. We've been able to kind of demonstrate from a materials perspective, performance perspective in the lab, and from an environmental perspective, that we can make products that the DOT, for example, would meet their specifications. Now, I wouldn't call this a material that you're going to go out and see in DOT roadways and things like that. But for example, non-structural concrete, you can certainly come up with something that meets the spec or the spirit of the DOT non-structural concrete. And then from the environmental side, there are just different ways to control the risk associated with it. So there are pathways to do it. I think the biggest challenge right now is trying to figure out more of the political economic side of things, because the contractor has to decide, well, why would I use this? Is it going to save me money? Am I going to have enough of it? Can I make sure that the quality meets the same standard day in and day out? And so it's a lot of those things. And so again, Pasco County, Palm Beach County, Miami-Dade County, Hillsborough County, and I'm sure I'm leaving someone off, but these local governments have really stepped up to the plate to be able to try to invest in this technology. If I could, Ken, I'd like to add, just as kind of an enticing thing, is that we submitted a proposal, I don't know if we get accepted or not, to the Department of Energy's, one of their programs. And their vision, if you can think of it this way, is that waste to energy plants, the electricity game is just not where it's at. And that what you really need to think about doing is, if you have all the raw building block ingredients in the ash, how can you use the heat and the energy from the combustion process, not to make electricity, but to make high value products out of it. Like, we're talking like, again, kiln feed or cement itself. Because, for example, you can take glass. I mean, we know this. And if you get it fine enough, it can be a replacement for coal fly ash when you make concrete. It's like a cementitious material. The challenge, though, is that it takes so much energy to be able to crush it so fine. Well, but if you're at a waste energy plant, it might make more sense to use that energy to provide that power to be able to do that and make a product than it is to sell electricity for so cheap that you just can't make the economics work. So there's a lot of kind of really new kind of cutting edge work that I think in the next decade or so here in Florida and elsewhere you'll see folks work on.
Which is funny. I was going to ask you something about the future. Let me get to one question from
Sure.
Clint Howerton. He's in Highlands County. He asks, what are the most effective ways to reduce the amount of contamination in recycling?
Yeah, well, that's a great question. I mean, I would say that for the most part, it's really because you don't control it. It's more about what the residents who are putting the materials in the bin. It's to have a very clear, focused message that everybody sees, and it's very simple. I think in a lot of cases that when you start just having so many things that are on that list of what can be put on the bin, eventually everybody puts everything in the bin. Right. And I know that might not be the best or most helpful answer in the world, but I think that's what we're all kind of learning, is that somehow we, as society, professionals, and government needs to figure out a way to get a message out there that is simple and easy to understand and not overcomplicated, and just demonstrate it to the public that if your heart is that you want to recycle. It's not, the better thing to do is not to put everything in the bin. It's to put the right things in the bin. And that's going to be something that I think local governments are just going to have to try and succeed or fail and refine and keep moving forward with.
Yep, I would agree with that. All right, so this goes back to what you were just saying a few minutes ago. Get out your crystal ball. So what is solid waste disposal issues in the future? So say 10, 20 years from now, where are we headed? What do we have to look forward to?
Wow, that's a tough question. I mean, I don't see, for example, that there are any major changes that are going to occur that are going to cause us to start moving away from landfills, for example. I mean, I think that if you were to project very far into the future, then what you're going to see is that there's going to come a point when you start simply, you're going to have more thermal treatment. So whether it's waste energy or some similar type of operation, you're going to probably have more segregated disposal, meaning that I could envision where this is going to come a point. I'll give you an example, and I know it sounds maybe a little bit science fiction like, but mixing a bunch of ash with a bunch of C&D with a bunch of garbage, that's probably the easiest thing to do if you have a landfill cell. But from a long-term management perspective, trying to just mix everything together doesn't make a lot of sense. So I think landfilling will continue, but it'll be just done in a little bit more smarter, strategic way. But again, I don't see that changing anytime soon. I don't know what in the landscape is going to change. Again, I think you're going to see this kind of refocus of recycling to try to do it smarter as opposed to doing everything, and that's going to be a combination of just good education and practice and experience, and then it's a matter of just opening up newer markets for materials. You hear lots of talk about, for example, gasification or some other type of system to use all these waste plastics to be able to convert into another type of fuel. But those technologies are there and they've been talked about. So I wouldn't, I'm a little reluctant to tell anybody that if we step 5 years in the future, even 10 years in the future, that it's going to look terribly different than it is now. I think this is a matter of probably a lot more small incremental steps, but understanding more about what the potential uses are, what the potential risks are, and just doing things in a smarter fashion. Smarter landfills, trying to do more thermal energy resource recovery in a smarter way and developing better markets. But the fundamental system, if we were to jump ahead a decade, might not look a whole lot different than it does now.
Okay. We did get one more question from a very, very bright project manager at Jones Edmunds, Carol Sawyer. She said, with respect to leachate, are you aware of any current Florida regulations that have changed wastewater effluent standards that will impact leachate acceptance? For example, changes in nitrogen levels and thresholds.
Yeah, that's a good question. I'm not saying those things haven't happened. I don't know that these utilities that are always saying we've got new requirements and standards, whether it's been something that's a specific regulation or whether it's a more of a site-by-site permitting, and it depends on what their discharge limits are and their particular discharge situation is. So I think I'd be a little remiss to say that no, there are no standards or no new regulations. I'm sure that there's new regulatory development, but I just don't know that it's one big blanket regulation all of a sudden has impacted everybody. I just think that everybody is tightening down more and more on their specific discharge standards. And that's going to affect some sites where it might not affect other sites.
Right. Well, I'd like to thank everyone for attending today, especially Dr. Tim Townsend. I really appreciate you coming on to our podcast today. Great information. I hope everyone got a lot out of it. If anyone has any other questions, you could always email me at kvogel@jonesedmunds.com, and I'll get the question to Tim if it's a question for Tim, or for me, we'll get you an answer. I am Ken Vogel, and this has been the Jones Edmunds Engineering Rocks podcast. Next month, we'll have the Alachua County Engineer, Ramon Gavarette, online, and we'll be asking him questions. And I know he took a trip up to DC recently and sat in Rose Garden, so we'll see how that trip went with him. So again, I appreciate it, and thank you again. Thanks, Tim.